Hi, everyone. Welcome back to episode 6 of Cosmos Crusaders. It's pretty crazy. We are now already on our sixth episode. We're going on, I think, 19 weeks since we started. So that's pretty cool. Um, this episode, we have Dr. Ronald Gamble, who is a research scientist at NASA Goddard and at UMD College Park. And this week's episode was really cool because he was our first like postdoc scientist. So though he's not exactly late career, he's still early career because he just got his position at NASA Goddard this year. It was a bit of a different type of interview because we had a lot of things to cover because he's had a longer career than like other people that we've done in our podcast so far, which was pretty cool and it ended up being pretty long. It's almost 2 hours. So look at the timestamps if you guys can watch the whole thing. There are a lot of really interesting parts. But before we start this week's episode, I guess me and Simi just wanted to sort of talk a little bit about what we've learned from doing the podcast so far and some things that have sort of stood out to us from all the different guests we've had. So we started this with the idea of sort of just bringing more awareness, highlighting the stories of people of color, minorities, and underrepresented individuals in the field, because I felt like a lot of the time our voices aren't heard as much as the majority. And from the guests we've had so far, which have all been pretty diverse, which I'm happy about, and we're going to try to continue to keep doing that. Everyone has a very different story, whether it has to do with how they started in the field and sort of the things that they've gone through in the field while they've been there. And I think that it's really special how we've been able to sort of hear everyone's individual stories and kind of just have them portray them in the way that sort of they seem like sort of just how they want to, and give them a space to sort of just express themselves, which has been really cool. And I think that everyone that we've had so far has been really honest about their experiences, which is really nice. And I think that I've learned a lot about how different people experience the field, and the different sort of challenges that people face that I might not necessarily have to think of on a day-to-day basis, which I think has been really good for me because it can help me be a better ally to different communities. So that's one of like the big things that I've taken away so far from what we've been doing. But I am interested to hear what Simi has taken away as someone who's not in the field, but will be going into a professional field very soon. So
Yeah, I mean, I agree with everything you said. And now, as I begin law school, in 2 weeks, um, I think that I gained a lot of insight from everyone that we've interviewed so far, and just like the obstacles that I might face in the future, just because of my identity. But I think the main takeaway that I have was just like, as long as I can remain resilient and focused on my goals and believe in myself, that I'll be able to accomplish anything. I think Dr. Gamble is a great example of that. He really just fought for what he wanted and was able to create his own path to get where he wanted to be. I think that's really like admirable for me and something I'm going to try to do as I begin my graduate career. Um, I'm really looking forward to all the rest of the stories that we're going to hear, and for the future of this podcast, because we are planning to expand it eventually to start looking at all the different fields, starting with law. So we just want to thank you for supporting us and for continuing to support us as we grow and have more and more episodes and move on to different areas of professional work. And yeah, I mean, this one's really great. We hope you guys enjoy this interview as much as we did. And thank you so much again.
yeah, thank you guys. Your support is very appreciated. And yeah, so I guess we'll just get right into Dr. Gamble's interview. It's a good one. So see you guys. Welcome back to another episode, and we are extremely excited to have Dr. Ronald Gamble as our guest. So, Dr. Gamble is a visiting assistant research scientist and cosmic origins research scientist at NASA Goddard. He got his undergraduate degree in physics, his master's degree in experimental condensed matter physics, and his PhD in theoretical astrophysics from North Carolina Agricultural and Technical State University. And his dissertation was titled On Gravitational Radiation, Nonlinear Wave Theory in a Viscoelastic Kerr-Lambda Spacetime. He completed the first physics-related dissertation at NCAT pertaining to the emission and propagation of nonlinear tensor mode gravitational waves from colliding black holes, which is pretty cool. And he is also the vice president of Black and Astro. So welcome to the show, Dr. Gamble. Thanks
Thank you for
for
having
being
me.
here. Yeah, of
Excited.
course. Of course, we're very excited.
Yeah, we really are. Thank you so much. And that's quite a track record you have going on over there. Just to start off with, could you describe a little bit about your current research?
Yeah.
We know, oh, sorry. No, go ahead.
Oh no, go ahead. I am the guest.
Just broadly, Gok and I understand it as you're studying relativistic jets that come from black holes, like theoretically. But we'd love to hear more about the details.
Yeah, so kind of in a nutshell, if I give you like an elevator speech, right? So for the general public, what do? Well, I use a combination of general relativity, so some heavy mathematics you might see behind me, and I use observational data to kind of infer or to decipher some of the physics that's going on in the relativistic jet. So we're talking high energy regime, right? So we're talking maybe MEV on up. So X-ray through gamma, cosmic ray, and maybe some other ultra high energy rays as well. But I'm looking at, if you can imagine, very, very close to the horizon of a black hole and the interface of the jet and the horizon. So what happens, according to physics, what happens in that regime, in the high energy realm of astrophysics? And I'm more focused on, how do we quantify angular momentum exchange, right? Between this very, very dense compact object, a black hole, and something that's very, very luminous, like a jet. And so we have to use techniques like X-ray polarimetry, radio polarimetry. So we're looking at polarization states within the jet to kind of quantify, to tell us, or to tell me or anybody else studying this area that you're on the right track, right? To develop your theory. The theory has to mature, and then you have to test it, right? The numbers have to match what we see. So that's the top level explanation of what I do, and it's very mathematically heavy for most astronomers, I should say, but I think it's very insightful to where the field is going for studying jets and jet emission theory. There's a lot of unknowns we don't know about, and so that captured my curiosity. Okay, and I told myself, well, pick one unanswered question, not 10, and just focus on that. And then once you get a focus, then your focus shrinks and shrinks and shrinks, and then you have now this one piece of information that turns into like a 15-page paper that you publish. And then you do it again, and you vary some results, and you keep doing it and keep doing it, and that's the science. And then you come up with the new stuff. And then you end up on interviews and podcasts and stuff like that.
That sounds really interesting. I also studied jets, so I'm very interested in your research. I study them from an observational perspective mostly, though I do want to get more into theory as my time at grad school goes on. So I was specifically wondering, so I study relativistic jets from core collapse supernovae, so sort of trying to understand why some type 1c broadline supernovae can release these relativistic jets while others don't, as long GRBs. So I was wondering if the same physical mechanisms that you study for jets from supermassive black holes can extend to relativistic jets that are released through core collapse supernovae as long GRBs.
So it could. So if you are a theorist, you have to make sure, one problem with developing new theories is you have to make sure that it applies to many, many different scenarios. So not just one specific thing, but you have to make sure that it's generalized so it can apply to other things as well. So in my work, I have to assume that the the black hole, for example, supermassive black holes that I study, they are compact objects. So you can, in theory, replace that with a pulsar, you can replace it with a neutron star, anything that is a source of strong gravity, right, has some of the same basic mechanisms as a black hole. Now, of course, the supermassive black hole is 1 billion times larger. We know that. But so for core collapse supernovae, the jets look very, very similar. And so there are some studies that kind of look at, well, is there a rotational mechanism involved for this collapse? And are there different types of core collapse mechanisms as well? Are we supposed to see the same type of emission in core collapse supernovae as we see in gamma ray bursts or gamma ray repeaters or radio jets or X-ray dominated jets and things of that nature? So we have to kind of apply it in a more general standpoint. We tested in one specific system, right? We don't have the time or the computers to do a lot of tests. That's a dream, right? Run it on the computer, test it for GRBs, AGN, pulsars, that'd be amazing. But the mathematics can apply to many different types of systems. So that would be very interesting to see that for core collapse supernovae, because there's a lot of unknowns we don't know about. And you can have, there are many other quantum mechanical implications for that as well. And so that becomes the weird interface to some of this research that's going on. So it's really cutting edge.
Yeah, it really sounds like it. But for me, like as someone who's not a scientist, I'm trying to get a better base level understanding of what you guys are talking about. But I'm still kind of confused about what the polarization of light like even means. I know that there's gravity stuff going on, but could you explain that a little bit more?
Yeah, so I would say you can kind of think of it as, if you think of it as kind of like kind of think of it as like a spinning top, right? So you have a spinning top, okay, and I know this is a very basic analogy, but for a spinning top can spin either clockwise or counterclockwise, right? And so if we're thinking about left and right polarizations of light, circular polarization, that's what we're talking about. We're talking about the handedness of the rotation of our electric fields as it propagates towards our eyes or our detectors. And so there are other combinations of polarizations. We have a prime example of you having polarization in your everyday life are sunglasses. So sunglasses polarize your light, and you see just a specific configuration of that light, and it hits your eye, and then now you can see the road in front of you and you can look good doing it at the same time, right? So thank you, Ray-Bans, for giving us polarized lenses. But that's the same science. So it's the same science that I use, the same fundamental physics that Goku might use in supernova collapse. It's the same science that other people might use. It's the same science that NASA uses when they study polarizations. And so that's what I'm referring to in terms of the theory has to apply to many different things, because we know all of these things happen, and we know that it's the same science that occurs for all these different types of phenomena. And so, yeah, if you go back and it's the spinning top, you spin one way, cool. Left polarization, you spin another way, right-handed polarization. And then if you apply that to kind of some other things as well, that's how we get some colors of light as also from different mechanisms due to polarization states. And so the list goes on and on from there, from your everyday applications of polarization. It's in your computer right now as well. And so you can think of switching, the key on and off, ones and zeros, as polarization. It's literally that simple. The mathematics is the same. So that's your everyday analogy to what I'm doing. Just take what I just described and apply it to supermassive black holes that are 1 million billion light years away. And it's the same thing.
That was a really good analogy. Yeah, polarization always confused me in undergrad, and I feel like even that analogy, hearing it now, like makes it even more clear to me. So thank you for that.
Yeah, optics was not the best course, but we have to take it, right?
Yeah, true. So I actually have a lot more questions I want to ask you about research, but I'm sure that we could talk about that some other time. So if we want to move on to your background now. So just starting off, kind of going way back, how did you know you wanted to study physics and astro growing up?
I didn't actually. So yeah, surprisingly, I didn't. I actually growing up, I think my mom always tells this story. 4 years old, I asked my mom, "Does the sun have fire?" And she's like, "I don't know how to answer that, but I assume so because we get light from it, and you can't look directly in the sun, so it must be hot." And so that's the answer I got from her recollection. And so I knew places like NASA, there were observatories existed. You know, I kind of knew how telescopes worked as a kid, but I didn't know that you could make a career out of and go to school for studying mathematical theories, period. And so growing up with it, I didn't have a lot of examples of that. We saw, of course, a lot of engineers, business people, people playing sports, the athletes, musicians, artists. There's a lot of artists in my family, but I'm the only physicist. So I am like one of the only pure scientists in my family. And so my mom, she's got a degree in biology from Fordham. Shout out to Fordham. But even still, you know, that's not astrophysics. And so I didn't know. I knew of the closest thing that I knew of was an aerospace engineer. I knew they had to deal with rockets, they had to deal with space travel of some kind. But then I took an astronomy elective in high school, and it kind of blew my mind. And my professor there, his name was Vonnie Hicks. Shout out to Mr. Hicks. If he's still at Enloe High School in Raleigh, North Carolina, he's gonna get a shout out, because that was like my first instance of physics and astronomy. So I had him for physics and astronomy. And that was actually the first time I realized, oh, I can do a lot of complicated things with this. These things are coming very easy to me. And so I took to it. And then I realized, oh, there's a bunch of math. Yikes. I was good at math from a very early age, but I wanted to know the science and not the math. I wanted to throw the math away and just do the science. But then my teacher at the time, he told me, well, no, you have to pair the two together. And so that's when I decided, oh, maybe I can major in this stuff. And so I majored in physics. I found out that you could be a physics major. This was maybe, I was like 16 years old. You could major in physics and just do physics. And then the rest is history from there. And clearly that's what I do, the physics and the math.
That's a really interesting story. Yeah, I guess most of the people that we've talked to so far have always been like, I wanted to study ever since like I was a kid. So it's really cool that you're able to find that passion in high school and sort of just go from there. That's awesome. So you talked a little bit about how there weren't many like astrophysicists, well, there weren't any astrophysicists in your family, and just sort of like there was a lack of representation in the field in general, because you didn't even really know that you could study physics until high school.
Yeah.
So I guess once you got into the field, how did the lack of representation sort of affect your view in astrophysics as sort of like the beginning stages of your career, like in undergrad, and like how those like close to you viewed the field, for example, like your family and like things of that nature?
Yeah, so it was, in the beginning, it was relatively hard. Well, it was very hard because not only, you know, the fact that there's maybe 1% of astrophysicists are either Black or Latino. And so that by itself was kind of astonishing. And I wasn't exposed to that very early, because I assumed, well, if I'm studying this at this age, well, then maybe there must be a lot more people studying this. And so early on, this is maybe freshman or sophomore year in undergrad, I come back home and I'm, you know, visiting the church that I grew up in. I'm visiting some family friends. I'm visiting some people in the community. I go back to an old, the club that I used to go to as a teenager. And people are asking me, what am I doing? And I'm like, oh, I'm majoring in physics. And I'm like, oh, yay, physics. And like, what are you going to do with that? I'm like, oh, what do you mean? Study black holes. What do you mean? This is awesome stuff. I'm like, no, what are you going to do when you come back home? Like, what kind of job are you going to have? Are you going to, how can that contribute to the community? I'm like, but it's not. And so it was a struggle trying to communicate the people that I grew up around, and these are mostly the older generation that weren't in those fields, right? Trying to explain to them that this is a job that I was very passionate about, and I had to learn how to be selfish in what I wanted to pursue, and not have it being influenced by someone else wanting me to come back home, right? To then either be an engineer, be a civil engineer, be a banker, or be an athlete, and then give $1 million back to my community or something like that. And so I had to be very comfortable in saying, well, this is what I wanted to do. This is what I'm very passionate about. And then once I went out into the world and realized, ooh, there's not a lot of us, not a lot of people that look like me doing what I'm doing, I then took it upon myself and said, okay, well, if there's not a lot of people doing this, then somebody has to do it. And so I'm not one to quit at something that I've already started. I'm very competitive. And so once I start on something, I want to finish it all the way through, and I want to be one of the best ones to do it. So I was taught very, very early on by my mother that if you are going to do something, do it well and do it completely. And so that's what I decided to do in undergrad. And I knew it would be a very, very hard path because I was doing it at an HBCU, so a historically Black institution. It's a very, very, I should say, almost impossible task to do. But I then met with one of my lifelong mentors, Dr. Bebe Kavedi. He's at North Carolina A&T right now, still teaching after 27 years. And so from then on, I met him in 2008. From then on, we're shooting for the moon and beyond. We just kept going. And so that's another influential person in my life for my career development that was like, okay, yeah, you can do this. Don't listen to anybody else. Don't listen to people that are saying that you can't do this. What are you going to get a job in? I'm like, well, I'm going to get a PhD. And I knew that as soon as I got my freshman year undergrad, they asked me, well, why did you want to be a physics major? So I can get a PhD in physics. But I know I have to do this first in order to get the PhD so that I can go home and people can call me doctor, and then I can tease. But really, I knew if you had a PhD, then you were really the boss of your research. And that's what I was after, being in control of the research that I did in my career. And so that's how I really got focused in physics in undergrad.
That's such an amazing story, like really admirable that you stuck to what you wanted from the beginning. And I'm glad you at least had some like people in your corner, because it must have been hard. But you mentioned that going to an HBCU is almost seen as an impossible task. I mean, I was under the impression that it was pretty uncommon in your field, but what do you think your positive experiences were there? Like, how is the overall vibe? And do you think that a lot of people, like, would you recommend it to people? And how would you like encourage people to change their views on HBCUs? Because it worked out for you.
Yeah, and I can't say that it was well, actually I would be remiss if I said that it was completely bad. It was an amazing experience. So don't get me wrong, it was a fantastic experience that if I actually had the chance to do it over again, I would probably choose the same path because of the people that I met along the way, and it's the sense of family that you have in your small department. My department had maybe 60 students in it, so that was both undergrad and graduate. So it was a very small department. We had maybe 8 or 9 teaching faculty, and then one other laboratory staff. And so that was it. And so we we would all come together as kind of like a small nitty gritty family. And just being on the HBCU campus, it then gives you another kind of source of pride that you can rely on, right? So even though I was maybe there were 3 of us that graduated in 2012. When we finished our degrees, there was 3 of us in that graduating class from physics. Yeah, and so, but we did other things on campus. And so the rest of the community on campus would look at us and say, how do you major in physics? They're like, well, it comes natural to us because everybody else in the STEM majors had to come through our department to take physics. And so we were kind of looked at as, okay, well, can you tutor me? Maybe. Are you gonna pay for my lunch? Sure. And so it was a sense of pride. And then being on an HBCU campus, there's homecoming every fall. And so that was a time that just kind of, and I can say this now because I'm far removed from undergrad, put your books away, put the homework away, put the exams away, midterms, what are those? And just relax, you have fun with your friends. You meet new alumni that graduated decades before you, and you share experiences. And then you come back once you graduate, and you keep doing that, and you'll have lifelong friends. I have lifelong friends from going there. And the professors remember me, my mentor is still there. I talk to him all the time. And so it's truly like a sense of community at an HBCU. And I'm encouraging more and more students to go to HBCUs, Black, white, Indigenous, Latino, Asian, it doesn't matter. Support these schools because they can provide another source of culture to the science, right? And so that's what I gained when I left the school. I gained a sense of culture that I can then contribute to the science. And then it makes it all fun. And so it's an amazing experience that if I could do it again, I probably would. Now I would do some things a little differently. Maybe I would study more, but it's an awesome feeling. And then once you meet other alumni, they're everywhere. It's like, oh, you went to A&T? Yeah, I did. Oh, Aggie, right. And now you have another friend. And so and my wife, she hates it when I see somebody, I'm like, oh, you Aggie? Yes. And then we go crazy and we're talking for 20 minutes as if we weren't strangers 30 seconds ago. And so it's awesome. It's truly awesome.
Yeah, that sounds like a really awesome experience. And talking about bringing culture to science, I think is very important. I think a lot of people in the field don't really view that as something that sort of has a place, which I thoroughly disagree with because science is done by people. Uh, so that is really cool. So next, you decided to stay at A&T for graduate school. So we were wondering why you decided to stay there for graduate school as well, and how did you end up doing a master's in experimental condensed matter physics and then transition to doing your PhD in theoretical astrophysics? Because those seem like 2 very different fields, like subfields in physics.
Yeah, it's an interesting story, and I occasionally will get this question asked me, why did you stay? It's like, well, when this was the beginning of my senior year undergrad, part 1. So I took an extra 5th year because I knew going into that senior year, that 4th year, I was not ready. And so I knew, okay, well, if I take my time in undergrad, okay, grad school will be there. MIT, Princeton, UMD, Caltech, Stanford, Berkeley, whatever, they're not going anywhere. They're going to be there. They were there for 200 years. They're going to be here for another 200 years. It's fine. And physics will always be here. As long as the universe is here, physics is here too. So I'm like, okay, so why am I rushing? Why the rush? So I took an extra year, and I'm so glad I did that because it gave me time to kind of slow down in my studies, and to really dive deeper into what I wanted to do in grad school. And so I figured that out very, very early on, and I started studying general relativity in undergrad. And this is, I didn't have a class for general relativity. This is something I picked up a book, Meisner, Thorne and Wheeler, and I looked at it and I read through it and I'm like, what the F? What is going on here? And then I said, all right, well, if I'm going to understand this, then I need to learn more math. And so that is when I made the decision, okay, well, I need to know more and more math, right? And so I did apply to other schools when I finished undergrad. Before I went into my master's, I didn't get in simply because I felt like I could have done better on the applications. And so that's another thing that I kind of drive home to some students that I mentor. Spend a lot of time on those applications because they definitely matter. And so I stayed, and I actually, me and my advisor, Dr. Cabetti, we wrote a grant to NSF for funding my master's, which would eventually parlay me into a PhD research in astrophysics. And it was not funded. And so we wrote another one. And then that one was kind of pending. And then NSF said, well, UNC Chapel Hill is like down the road from you. You guys should go work with them. Because A&T wasn't known for astronomy, but UNC Chapel Hill was. And so I said, well, but they're an hour away. I'm not going to drive every day to UNC Chapel Hill. I can't do that. And so it was unfunded. And so my advisor, one of the most resourceful persons I've ever met, he put together a project that he would do with another person on campus in mechanical engineering. And that's how I got connected and interwoven into experimental condensed matter. So we studied high temperature superconductivity because he knew I wanted to stay in grad school. He knew I needed to do something and not stop. Like he knew this was an investment in my potential, which I'm forever grateful for because it was awesome. And so in order for me to keep going and not stop, I did the master's. I stayed at A&T. But I also told him, well, if I'm staying, then I want to teach. And so that's when I first started teaching at A&T. And I liked it at first. I was like, okay, this is kind of fun, teaching people physics, and they were confused at first, but then once they figured it out, see, like your face right now, it's like, okay, yes, you get it, yes. And then you want to keep teaching, you want to tell them more until you find out they're not a physics major, and so they didn't take calculus 3 and differential equations yet. And so you learn to communicate the science better teaching it. And so that's what I picked up on. So I had kind of like a dual threat for my master's: stay in school, do something, right? Which I actually enjoyed, superconductivity. I played around in the lab one day and I made so we were using quartz. We were making high temperature superconductors, so yttrium, barium, copper oxide on quartz thin films. And so we would create those by pulse laser deposition. I use a krypton laser, about maybe like 550 to 600 kilojoules of power. And so we create a laser, create the plasma, deposit the superconducting powder on there, and you have this thin film, which it almost looks like the surface of your phone, right? So it looks like that reflective surface, but it's a superconductor. And so I played it around in the lab one day and I made a clear superconductor. Normally they're opaque, they're black, but I made a clear one. And my advisor was like, how did you do this? I'm like, well, you're not gonna like it, but I took some stuff out of your cabinet and kind of threw them into the vacuum chamber and I shot a laser at it to see if it'll work. And he's like, but did it? It's like, it kind of did. It's like, can you do it again? Like, maybe. But let me write the equations down first before I lose this idea. And so that then sparked what I did in grad school. And so I did not initially want to stay for my PhD. I got waitlisted at UMD College Park, where I am now faculty at. So ironically, and I got waitlisted for Princeton astrophysics. I got into the grad school, but I did not have funding. So of course, if you don't have funding for grad school, you don't go. So I stayed at A&T, and the story of what I told you very, very early on in undergrad about staying at an HBCU then resonated back. And then I really made a much stronger commitment to saying, all right, well, if someone's going to get a PhD in astrophysics here, then I'm going to be the first one to do it. And so years and years go by, I finished, I had an awesome time. I'm sure we're about to jump into that work, but that's the reason why I stayed at A&T. And I'm kind of glad I did it, because I can show students coming up now that, hey, this path is possible. You can go from 0 to Mount Olympus or NASA through this path. So there's a path that's very doable. It might be difficult, but it's very possible, and it's very real. And so would I want to stay in grad school again? Maybe. But everything that I learned, I'm eternally grateful for, because it truly made the scientist that's talking to you today. So it gave me a sense of resilience that I can then teach my students how to use.
Yeah, that's super inspiring. And in your position now, it just proves that like hard work and dedication really does pay off, no matter how many steps you have to take. So it's pretty obvious that you always encourage people to take whatever route fits them, even though it might be uncommon. But how do you think that like other scientists and other people in the field can help reduce the stigma around the HBCU route?
Yeah, you have to, I would say people have to look at, again, it's a culture thing, right? So people have to look at HBCU students and just HBCUs in general. And this applies to other MSIs, HSIs, indigenous colleges as well, right? Of looking at not just the science that is coming out, right? Not the fact that some of these schools are, well, most of these schools are not large R1 institutions, right? So they're not Stanford doing a bunch of research, or if you will, but they are smaller schools, but they have the people that drive the science. So you have to look at some of these schools as, well, this is your source of part of the culture that goes into the science. The science did not start in a lab. It started with people looking up. And so at some of these schools, you go back, you're transported back to the people looking up, instead of people just being buried in a lab and trying to come up with new intuitive ideas and not getting anywhere. Well, you got to look up. We're astronomers or astrophysicists or scientists. We looked up initially. And so part of that is, not just identifying, well, yes, that's the constellation, Ursa Major, there's Ursa Minor, whatever. Yeah, that's where we started, right? But our telescopes, we're devising scientific methods that do the exact same thing that the people are doing. We're looking up, we're pointing our telescopes up. And so if you want the creative, if you want the intuitive ideas, if you want the fresh ideas, right, that are kind of, that have been marinating, they've been fermenting, right, in this sea of possibility, right? Well, you have to look at these HBCUs, because that's where it's at, right? So part of the struggle, it kind of helps kind of season, adds flavor to these new and fresh ideas, because we had to think about some of these things very, very creatively with some of the limited resources that we had. And so if you get someone like that coming out of some of these schools and they're doing the same caliber research as someone at Stanford, shouldn't they be able to do it cheaper? In terms of, if I'm thinking of a grant, well, that person can save me money. If I'm a PI, well, they know how to do it more efficiently, really. And so there's a balance. And so this is also happening at the large R1s as well. So it's not something that's exclusive to HBCUs, but that is a source, right? So it's a cultural source that we can tap into. And there's fantastic students at these schools. All they need is just the opportunity. That's it. and access to resources. That's truly all they need. They have the brilliance, the intelligence, the intuition, they have it all. They just need exposure, that's it. Just to tell them, hey, your school may not have a PhD in astrophysics, but you can get into another school that has it and do fantastic things. So I think that's really where the attention needs to be. And to make sure that we're not squandering the students that are coming through there, right? We're investing in these schools so that we can build up many, many different types of scientists, right? Because that's how we got to where we are. That's how we're able to do general relativity. Einstein reached out to many other people to put this together. He didn't do it by himself. And so I think that's what we really need to do.
Yeah, that was really powerful, and I think that's a really good message to spread to our community. I think more people with your mindset would make it a much better place. So now finishing up with your time doing your PhD, I guess if you could just describe sort of the main finding or a couple of your main findings of your thesis, which has a very impressive title. So I guess just describing a little bit about sort of what your thesis was about and like what you ended up finding out. Pretty interested.
Yeah, so this is another interesting topic. And it's one that I'm still currently developing. So this is far from finished, but back in grad school, in my studies of general relativity, I came to ask my graduate advisor at the time, that was Dr. Kenneth Flurchick. And so I asked him, well, what if the metric of space-time changed in time? What if that was time dependent? And he said, that doesn't make sense. No, you're reading it wrong. Go back, redo the math. And I'm like, okay, well, but I read it, but I have these questions, just humor me. He's like, okay, well, that would mean your ruler, if you will, changes in shape as time changes. So imagine you trying to measure something with a ruler, but the ruler changes. Oh, well, that's not really gonna work. And so then I asked him, like, okay, well, what if, we have the rubber sheet analogy for space-time, right? Put a mass there, it stretches, space-time curvature, real simple. That's general relativity in a nutshell. And so I asked him, all right, well, what if instead of the rubber sheet, right? What if I had a ball of putty that was space-time? I have a ball of putty that was space-time. And I said, all right, well, imagine this putty as behaving like a fluid. The putty can stretch, you can twist it around, it can flow a little bit if you heat it up. So it's like a fluid, right? So you're thinking Navier-Stokes, fluid mechanics, yay, mathematics. And so I asked him again, all right, well, what if that was time dependent? And he said, well, again, it's not gonna work. He was a very old school physicist. He's an old school theorist. He's from Jersey, went to Catholic school. So he's one of them like, no, do it my way. And so I then said, all right, well, what if the metric of space-time, right? So we have general relativity. What if the metric of space-time didn't necessarily change, but we added a change to it, right? So instead of you actually stretching the ruler, what if you just added another ruler? And then that extended your length, if you will, right? So now what if I took the same putty analogy and I stretched it out and I shrunk it back and I kept doing that, right? And he said, well, that's gravitational waves essentially. I'm like, yeah, that. What if we did that? He's like, did you read about gravitational waves? I'm like, no, what's that? It's like, so he hands me this thick, and it's somewhere in my office, this book that's like this thick, strictly for gravitational waves, and it's like a black hole Bible. And he said, all right, read this, come back. It's 600 pages. What do you mean, read this? So I read, I did what he told me to. I tried to read it. And by then I knew enough mathematics to kind of, I meandered around it. And I come back to him, it's like, all right, I know what I want to do for my dissertation work. He's like, all right, well, what is it? It's like, I want to know if we can describe gravitational waves as elastic. And he said, huh, that was the first time I stumped him in a question. And I knew, yes, I'm onto something. And then he said, oh, that's been done before. I'm like, crap. And then I come back to him again and I said, well, no, not that way. Because I actually looked that up, not that way. Go back to the ball, the putty ball. But what if gravitational waves acted like that? And he said, well, you might have something new then. I'm like, okay. And so I go off, I hide for like a whole semester, and I come back with this proposal for my dissertation work. This is right before my qualifier exams. And so I then presented the idea of, and this is the general synopsis of my dissertation, the general idea of what if I take gravitational waves from black hole binaries, okay, so that's known. And what if I said, well, what if we describe them using some type of elastic interpretation of spacetime, right? And so we then go off, we develop this extension to general relativity, if you will, that kind of takes that general idea. And then one of the results was, well, it worked. At the time, this was when LIGO like first turned on. So this is just like JWST is everywhere now. LIGO was everywhere back in like 2015. So it's LIGO everything during this time. And all of this new information on gravitational wave detections became available. And we said, ooh, let's test this thing out. And so we tested it on some LIGO data, and we actually recovered one of the linearized solutions using this theory. And so that's one of the results of my dissertation. And then I told him, okay, well, but what about the energy? What about the other side of the equation, right? He said, okay, well, what do you mean by that? What about the energy? It's like, well, there's the second law of thermo. It's like, don't do that. I'm like, but Hawking did. He's like, no, don't do that. I'm like, well, why not? And he's like, well, that involves quantum field theory. We don't know how to incorporate quantum field theory in general relativity yet. We still don't know how to do that. And so I said, okay, well, I went back into the lab, crunch, math, right? Code. And I came up with the other side, the other half of my dissertation, which involved describing the genesis of these elastic oscillations based off of the black hole mechanics that Hawking, Bardeen, and Carter put together, and extending those to include this elastic interpretation. So I had two extensions, both on the geometric side from Einstein and general relativity, and then on the thermodynamic side from Hawking, Bardeen, and Carter, that theory. And so I combined the two together, and one of the principal results of the work was coming up with a small scale numerical model of the spin deformation of Kerr black holes. And I reconstructed the binary pair for, gosh, what is it's GW 150917, I think is the gravitational wave detection. And so I used that data. I reconstructed the space-time geometries for both those separate black holes. And then I modeled their deformation post-merger. So, and you can see how the mass would increase, right? But the spin dropped a little bit. And so I was able to calculate that out to maybe like 4 or 5 decimal places. So it was actually fairly accurate to reconstruct the new geometry, the horizons and the black holes and all that numerically. So we used a small scale model of numerical relativity to do that. And we generated a 3D model of this for the spin decay of a black hole. And it matched with the LIGO data. And so that's what I did in grad school. It's 193 pages of like mathematics and code. And I wrote the whole thing in LaTeX. And so that's what a principal result of from grad school, and I'm still working on that theory. It's on that board in my home office, and it's continuing to evolve. So you should see more results maybe within the next year or so after publication. Yeah. So long story less long. That's what I did in grad school.
Wow, that's pretty crazy. That's pretty big time. Yeah, I'm definitely gonna try to check out that thesis when I have a chance. That sounds really interesting. I love to read about more of the details. Um, so now getting into your postdoc years. So you stayed at A&T for your postdoc, and then you went on to do another postdoc at the Defense Threat Reduction Agency and National Strategic Research Institute. So could you sort of describe how you got these positions and what your experiences were like during those years? I remember you mentioned during your AAS talk that you can't talk much about what you did during the defense threat year. So it's okay if you can't talk too much about that, but just sort of like generally, how did you get those positions and like what did you sort of do during them?
Yeah, so this is another like interesting caveat to my journey. So this kind of blows the masters in condensed matter theory and experimentation kind of out the water, because this first postdoc wasn't in a physics department. It was actually in bioengineering and biomedical engineering. So this was a recommendation from my graduate advisor, and he thought, okay, well, I didn't get I didn't get to go to some other postdocs that I had applied to, because at the time, those postdocs in theory, you had to be like extremely competitive for. And so this was another instance of, oh, I didn't know the field was like this. And so it's you kind of, at a small school, you're kind of sheltered, if you will, from some of these things. And then you go out in the world and it's like, wow, man, maybe I should have published more in grad school. Because these guys are coming out with like 16 publications going into the postdocs. And I'm like, whoa. And so I stayed there. He knew I had a passion for teaching, right? And he knew that I would benefit from teaching more. And so in grad school, we had both developed the curriculum for 2 other physics courses. And so he said, all right, well, this is a postdoc that's kind of doing the same thing, but you have more freedom to do it. And so I applied to the postdoc, and the department chair in biomedical engineering asked me, well, you're not an engineer. It's like, yeah, but you're looking for someone to help develop physics labs and physics courses and the mathematics courses that you need. It's like, and I can do that because I'm a theoretical physicist. And he said, okay, well, give me a 5-minute lecture on the divergence theorem from calculus 3. I'm like, cool. And I wrote out the proof for the divergence theorem in 5 minutes on the board in his office. This is in an interview for the job. And he was like, but I explained it to him just as if someone who never took physics, who had never taken mathematics, and at the end of that, he understood. He's like, okay, so we have to write out these 7 courses that we wanted. He starts telling me all this stuff about what he's doing as part of this grant that he wrote for NSF. And I'm like, okay, did I get the job? It's like, okay, yeah. When can you start? I'm like, now. I'm here. And so it's kind of how I got the job or the position, that first postdoc. And it was centered around, so it was part of the NSF Project Red. So this is revitalizing engineering design courses. And so I was a postdoctoral fellow in that program, on that grant. And my job was to design, develop, implement, and teach a set of 5 new classes that were both a part of math, numerical calculus based. So I developed 2 calculus laboratories, if you will. So these are all done on the computer. So this is computational calculus. So this is for calculus 2 and calculus 3. And I'm teaching this to biomedical engineers who barely take physics 2. And so some stop at calculus 3. And so, but the lab is taught to freshmen. So I have to teach numerical calculus to freshmen and sophomores. And so I developed this course that's both equal parts rigor and, some of the application to their major in biomedical engineering. And it took off. It was great. The other courses that I designed were a biophysics lab and lecture. It was a pair of courses. It was a lab and lecture. And then also a bioenergy interactions course and lab, which kind of was centered around some of the biotransport mechanisms. This is things like electrolysis, electrophoresis, catalytic reactions, reaction rates, bioluminescence. There are some cellular responses to radiation sources and ionic transports. We're looking at diffusion. By the end of this course, they would have learned Stokes' theorem, the curl, vector calculus, diffusion, and they would have learned how to do it all in MATLAB on the computer to write code for solving these problems. And so those were 4 of the 5 classes that I had designed. The 5th one was an upper level course. And I don't know why they put me in this, but it was anatomy and physiology. So it was engineering analysis of physiology. And at first I'm like, gosh, the last time I took biology was in high school and I'm a postdoc. I'm like, okay, how do I? So I find their textbook that they had before and I read overnight. I just read through the textbook. I'm like, okay, now let's do this. We'll do this. We'll do this. We'll do this. Okay, cool. So we started with reaction rate equations. Okay, well, what happens when you put concentration of potassium on one side of some cell wall or some barrier, some membrane, and you put sodium or calcium or chlorine or something else, some other ion, some other salt on the other side? Well, what happens? Well, they want to mix together. Okay, positive, negative charges. Cool, physics 1 exists, right? And so that is, at that first semester was rough. It was very rough. And my old advisor at the time said, yeah, I heard from your department chair that you're kind of teaching this course a little rough. I'm like, how did you hear about this? Well, he asked me if he picked the right guy. I'm like, oh crap. And so I stepped it up a little bit. I read some more and realized, okay, well, I'm going to take a more physical approach to this, add more math and add more math and add more math. And then the course became harder for the student. But if you got through that course, you could do you were ready for anything in grad school for biomedical engineering because you've seen it all through that course. And I built a reputation for having hard courses. And some students avoided me at the beginning, and then they realized you have to take Dr. Gamble's course. Do I have to? Yes. If you want to graduate, you have to go through him. And so that was the position there, and I did that for about 1.5 years. So at the end of that, I ended that in 2019. So by 2019, I had taught at A&T for 7 years, and by the end of that, I had designed 7 courses. I taught undergrad, graduate, physics, math, biomedical engineering, and 1 computer science course. And I did a lot at A&T, and then I had to leave and go to the DoD. So yeah, that's what I did in the first postdoc that I had there. It's a lot of stuff.
That does sound like a lot of stuff, but you made it work, even though it was kind of hard for the students. But it seems like the postdocs that you were doing weren't really in line with your end goal. how did you sort of like keep your mentality strong and keep pushing throughout this like kind of like state of limbo?
Yeah, I would continually do my continue the work that I did in grad school on the side. So when, if I had downtime either on the weekends or sometimes in the evening, and this is 2018, so now I'm married, and my wife's like, no, come to bed. What are you doing? I'm like, but I'm working. This is gonna work out one day. Trust me. And this is 2018. I mean, she's like, is it though? Like, yes. Clearly it worked out. I'm at NASA now, so something worked. But that's what I did on the side, because I knew, okay, well, this postdoc's temporary. Okay, cool. I can get another postdoc. The second postdoc I had, I didn't search for. They found me. Yeah, so, and I had no idea they existed. Before I looked them up, I had no idea they existed. They found me, they reached out on LinkedIn and said, hey, you really fit what we're looking for. And I'm like, do I? Okay, sure, I'm currently on the market. I'll take your job since it pays like 30% more than the other postdoc I was looking at. And so it's, again, this is another instance of me working on the side, but I did have the state of mind to ask them in an interview for the second postdoc in the DoD if I wanted to publish work of mine that was unrelated to my current job task, could I have funding to do that? And they said, yes, we encourage that. I'm like, okay, great. When do I start? Because I knew, all right, that's a place I needed to be at to continue working. And so I put out 2 other papers during that time span. One of them was submitted to Physical Review D. Physical Review D said no, and I was heartbroken. I was heartbroken. But then it taught me a lesson of, okay, well, one no, there's going to be a yes somewhere else. Keep working. So I kept developing, kept working, and I kept working until I had my interview with NASA. And I told them, well, if you want to know what I did, I have these slides ready. I had 30 slides prepared before my interview, because I'm like, all right, I'm not going to get another chance to talk to NASA, maybe. And so I had these slides prepared, and they asked me, who did you work with? Once you finished grad school, who did you work with? Because you went to DoD and you did this biomedical engineering post. Who did you work with? It's like, I was by myself. And they were like, wow. They were speechless. And so I say all that to kind of compound the idea again of having that resilience. If you want to do something, you have to be okay with not being paid for it in the beginning. It's okay if you're not paid for it, if you're not compensated for it, if they don't accept your paper, it's okay. Keep doing it, because at some point, all this hard work is going to pay off. And now to me, it seems like, okay, well, I went from here and I kind of like skipped the line up to the top. And now I'm just here. Now, NASA's like, Ron, just keep doing what you're doing. Publish. Do whatever you want sometimes. And, it's like, okay, this is what I wanted all along. And so it was a hard lesson to learn of resilience. Resilience is hard to learn. But once you get it, it's like, okay, I'm unstoppable. Until you get, you try to publish again and they say no or something, or you go for funding and they say no, but that's part of the job, right? But that's what I did to continue my interest, to continue building that resume in astrophysics, because I knew at some point I'm gonna get my break. I'm gonna get into the field, and that's what happened.
Wow, a lot of just believing in yourself and kind of this one door closes, another one opens kind of thing. That seems like a theme for you. But
That's really awesome. So now you're a visiting assistant research scientist and cosmic origin scientist at Goddard and also UMD. You mentioned a little bit about what you're doing there now, but like, how did you end up there? Did they also invite you for the interview? Did they reach out to you or?
They did. So my job, it wasn't widely advertised, I should say. So this is, you guys are Goku, you'll meet this point in your career. You guys are still very early career, but once you finish grad school, you finish your postdoc, you'll go out and get some tenure track or some other position. And these are the jobs that are called direct hires. And so these are jobs that they are looking for people with very, very specific set of skills. And it just so happened that my resume popped up. I sent out a cold email. I randomly emailed or responded to some announcement of a position that would have been posted online and advertised during the summer. So this is summer 2021, right? So this is 2021. And I sent out an email, this is about March, and I didn't get anything back. And I'm like, all right, well, it's out there. Somebody has my resume. Maybe they'll contact me back. 2 weeks later, the deputy director of the Astrophysics Science Division reaches out and she says, hey, yeah, we read through your resume. We read through your research statement. That's some pretty interesting stuff. We want to talk more. I'm like, oh, you do? Cool. Okay, yeah, you're NASA. Why not? And so I talked to them. And so I tell them about what I did, tell them about my journey, some of the same things that I've shared with you today. And they were like, okay, but most of this you've been navigating alone. I was like, yeah, it's been very solitary. And they didn't look at that as a hindrance, but something that would aid in the position that they were trying to fill. Because then that showed that showed independence. So it showed drive, it showed independence, and it showed that I could manage a bunch of different things. And so that's part of how I got my job. And of course, there are many, many different rounds to an interview. And so after that first talk, I was like, okay, yeah, reach out if you are interested. And I'm like, okay, well, I'm over here kind of thing. And it's maybe a few weeks go by and they ask for an interview with, again, it's her again, the deputy director, and then also other lab chiefs. So I met the gravitational astrophysics lab chief, great guy. These are great people, who was very interested in what I did. And then I was presented kind of with a fork in the road because I didn't have a more traditional astrophysics postdoc position. I was offered, all right, well, I'm thinking to myself, do I apply to the NPP again? Where I got to final rounds and then they said, well, you didn't have enough publications, but you liked the proposal. And so then I was like, okay, do I do that again? Or do I take a chance and take this other route that was presented to me? And this is how I got exposed to CREST. So this is the Center for, this is my employer. This is the Center for Research and Exploration in Space Sciences and Technology, CREST. Yay. So Lee Mundy and Lee Sheen at UMD, you should be proud. I remember the acronym for CREST, if you're watching this. But that's my exposure. And I kind of took that. And then the extra position that was kind of tacked onto this, they said, all right, well, if you're going to go this route, then are you interested in doing diversity, equity, inclusion things? I'm like, yeah. Well, is that part of the position? I'm like, well, it doesn't have to be, but if you do it, I think we might be able to, add some extra incentive on there, which, for for big boy and big girl jobs, that's negotiating salary, basically. And so I'm like, I'm not going to say, no, you're NASA. What? No, of course not. But at the same time, I'm like, okay, well, what would I be doing? And this is outreach, this is recruitment, this is both diversity, equity, inclusion, accessibility efforts, both interior to NASA, exterior to NASA, trying to be a face that NASA Goddard and the Astrophysics Science Division can kind of attach to some of their data efforts, right? And then to have, again, just like the culture, to bring in this sense of culture that they didn't have before. So they didn't have somebody who was purely from the HBCU route before. So I was like the first one. And so after I realized that, I'm like, wow, all right, I got my work. Like, I got a lot of work to do then. I can't be the only one here. And so that's part of how I got my job. And then I realized that UMD has like 25 different faculty titles. And I was presented with 2, and I'm like, okay, what's a visiting assistant research scientist? And I'm talking with the folks at UMD. It's like, well, essentially you're like visiting research faculty. I'm like, am I teaching? It's like, no, but you can adjunct if you wanted to at some point later, 2 years after you start. And so I'm like, okay, cool, I'll take it. Cool. And so my position was a hybrid one. So it was a first of its kind of doing DEI outreach and recruitment and other internal and external efforts, and a combination of independent research. And this is research that, of course, you have to submit a research plan, right, when you initially start. But this was entirely whatever I wanted to do. If it was NASA related or NASA directed, I can do whatever it was. And so I'm like a kid in a candy shop, like, oh, can I do general relativity? She's like, and the deputy director is like, if you can tie it back to a mission architecture or something, go for it. And I'm like, cool. So I go out and I'm like, yeah, jets. Because I wasn't able to do jets in grad school. And I'm like, yes, jets, jets, jets. And then she comes back, it's like, all right, which ones? I'm like, oh, what do you mean, which ones? There's one. It's like, no, there's many, many different types of jets. And so this was now my opportunity to deep dive, go in the deep end of cutting edge astrophysics theory. And so that's what I did the first summer before I started. That's what I did. And so I had an opportunity to learn a lot. I went to the Fermi School at Goddard. It was hosted between NASA Goddard and some other folks out at Stanford. And so it was virtual because COVID was still real then. And so that was my first task, was to put together a research plan to start my position. And so that's how I got my job. There's a lot of in-betweens in there that nobody wants to hear about because it's red tape and paperwork and HR this and HR that and stuff. But that's how I got my position, taking a chance and sending out a cold email to this NASA administrator to then say, all right, yes, I don't have as many publications as some. I didn't have an astrophysics postdoc. I do have an astrophysics dissertation. I do have 3 degrees in physics. I have taught for 7 years. I do have government experience in the DoD. I can say that we managed very large projects that involved some aspect of nuclear physics. And that's all I can say. That's all I can say. And so if you're working in the government, then you know, oh, well, that's relevant experience. And so the teaching was relevant experience. The independent research I did on the side was relevant experience. because I'm literally doing the same thing now. I'm just getting paid for it, finally. And so that's how my position was given to me, or that's how I earned my position. And then last March, I applied to be the Cosmic Origins scientist. As we know, Cosmic Origins is kind of agency-wide. It's Cosmic Origins, Physics of the Cosmos, and Exoplanet Explorers are the three pillars of NASA Science Mission Directorate, right? And NASA S&D. And so I applied to be a support scientist there, and my position kind of got elevated slightly because I was doing the work. I was doing more than just, you know, this small communicative supportive role, just sending out the newsletters and writing emails and stuff like that. Oh no, we're doing more than that. We're putting on programs, we're organizing workshops, we're putting on sessions like you saw at AAS. That's part of my Cosmic Origins work. And so it culminates into this now very dynamic position that I have, very unique position that I have at NASA, where I get to go out and not just communicate the science, not just recruit more people to do the science, but I get to do the science as well. So it's kind of like a trifecta of all the things that I was doing before I got to NASA. And I'm now doing it in one position. I'm getting paid for it. And then I get to invite other people to try to do the same thing with me. And so I love it. It's an awesome position. It's a dream job. If I had to do it all over again just to get back to this position, I would probably do it because it's an amazing opportunity. I love my work.
Wow, that's really amazing. It's truly a testament of your resilience and your hard work. I'm really happy for you. That was an amazing story. Yeah, that's the stuff they make movies out of. Like, that's crazy.
If somebody wants to make a movie, let me know.
So I guess, wow, yeah, that was really cool. So now talking about sort of like your experiences that you've had at NASA so far, what has your experience been like so far as an Afro-Latino who's graduated with degrees from HBCUs? Has there been any pushbacks and struggles that you faced because you've come from these underrepresented backgrounds?
Yeah, so this is kind of the touchy tearjerker part. So disclaimer, get your tissues out. But so again, this is part of what I am referring to in terms of it being a near impossible task, right? So this is all throughout my journey from undergrad, even today, even 5 years post PhD now. I'm still facing some adversity, right? So I'm still being looked at as kind of someone some people might look at my position as a diversity hire, if you will. I've heard that before. In grad school, I remember presenting posters at the American Physical Society meetings and being told that, because I got my degrees are coming from HBCUs and not large institutions that are well known for physics and astronomy and all that, that my degrees didn't count. And I have to go to another school and get them all over again if I wanted to get a job in the field or something like that. And so it's that constant barrage of things at every stage. It's always there, but it's always a reminder to keep going, right? So I know I'm not the only one who's doing this, who's going through this, who are hearing these words. Someone who has less tenacity than I did probably heard these words and they've left the field now, and we don't know who they are because they're out of the community. So we don't have a reach for them. We can't get them. But the ones that are still here, right? I try to reach out to. I make myself available. And even so, when I first got hired at NASA and UMD through CREST, even then I was still faced with some online attacks and things like that, saying that, why would UMD hire this URM? And that is a literal quote, literal quote there. And so it's like, okay, well, yeah, there's some people that don't like the fact that I am here, that I am manifest, that I exist, right? And some feel threatened, but what can you do? Because I'm only going to get better, and I'm only going to invite more people to join me, whether they're black, purple, yellow, green, red, clear, whatever. Doesn't matter. If you're about the cause, you're about expanding this field, then yeah, I want to work with you. And so that is, it's a hard pill to swallow, right? If you're coming through a similar background that I have, similar experiences, it's a hard pill to swallow. And it's not just at HBCUs either. It's at PWIs, it's at large R1s. And so it's everywhere, right? But again, I'd rather it be me who has learned how to have the tough skin. I learned early on, I was a middle child. So my brothers and sisters used to beat up on me all the time. So I built, metaphorically, I built up a tough skin, right? I have a tough exterior. It takes a lot to put me down now. And so I would rather take on that beating than to have one of my students take that on. And so that's part of my journey, part of the hard parts, right? Part of the resilience again. But I'm sure I haven't heard the last of it. And so this is part of still continuing part of the drive, so that we know those comments are going to be there. We know those people exist. We know they're going to be there. We know we're going to hear that type of language, but we have to learn how to ignore it and use it as motivation, as, okay, well, if you think I'm going to fail, then watch me succeed, because I've got no other option but to make it. And we have if my father sees this, which he probably will, we have a saying amongst each other. In the Gamble family, you have a saying of either we're going to make it or we're going to make it, period. And so there's no other option. Either you're going to complete your task or you're going to complete it. There's no other option but to keep moving forward and to complete it, to make it. And so that's the mentality I try to keep. It's hard to do that every day, day in and day out. It's very hard. And then especially to see other people that you care about in the field. If I see one day, go cool, that some people are attacked, I'm going to be upset. I'm going to be furious. And I'm not going to say that I'm going to fight somebody, because that's not professional. But there are more professional ways to defend somebody, to combat that type of language, that type of hatred or whatever. And so that's what I've learned how to do. And I try to do that. We try to do that in Black and Astro. That is why Black and Astro exists, so that we can reach out. It's not just for Black and brown astronomers, it's for a lot of other people as well. So it's for you all as well. It's not just for us, but it's a space that is welcoming to show people, hey, block out all the noise. There are some great things happening. We can build some fantastic things here if we ignore these people over here talking smack and other things. And so you have to have a tough skin to be in this field. But I think, you can definitely do it. So that's my imparting wisdom from my experiences, getting to where I'm at now.
Yeah, thank you for sharing all that, Dr. Gamble. I think that's really honest, and it really can show the community how tough things are for people that a lot of people don't even realize, because they don't have to go through those things. So I think bringing awareness to the fact that all these really horrible things happen to you and you're still going. It's testament to your hard work and your resilience, but also you shouldn't have to be so
Right.
resilient. Like that shouldn't be the way things are. That's why we started this podcast, so we can highlight stories like yours, so we could show the state of the community and how we can make things better. And you have a ton of allies at UMD, me included, and all my cohort, and like a lot of people that are going to support you. And we are really, really excited that you're going to be part of our program for the upcoming years. And yeah, I can't wait to keep working with you as your years go on.
Yeah.
So now getting into a little bit about your intersectional identity, because you are an Afro-Latino. So has that impacted the focus that you've placed on sort of supporting underrepresented students to pursue academia? Have you ever felt that you had to prioritize a certain part of your identity over another, even though both your ethnicities are sort of minorities in the field?
That's an interesting question. I don't think I've ever been asked that before. Have I ever had to prioritize one over the other? I don't think, I think it's very rare, I should say. There is an unspoken, so just like you have comments coming from other, racist sources, if you will, right? That are usually the binary, Black, white, or white, Asian, or, what have you. Some, and this exists in the Latino community, the Latinx community, there's colorism. And so even you have inter-ethnic divisions, if you will. And so I say that it's a rare occurrence to prioritize one over the other, because even when I'm sometimes in completely Latinx or Latine spaces, I'm still looked at for some as Black and not a fellow Latino, because either I'm either the way I look or how I talk sometimes, or and I'm intermediate in my Spanish. I can't say that I'm fluent. I lost that as a child, but I am intermediate in my Spanish conversationally. So, but if I go to Spain, no, I don't think I will be looked at as a Latino. I think they'll look at me as, oh, are you a Black person from America? And I'll respond to them in Spanish, and I get this surprised face like, oh, yeah, I'm kind of one of you guys. Especially now, when I am now that is more, I would say, Eurocentric spaces, right? Now, if I'm in Latin Caribbean spaces, I'm instantaneously transported to like my people. I'm instantly recognized. Even for people I haven't even met yet, they're like, oh, where are you from? It's like, where's your family from? They automatically assume, okay, there's something else about you that I can't quite place, but I know we have a commonality. And so those are the spaces that again, it's another instance of not really prioritizing one of the other. They're kind of intermingled, right? So it's very rare that I prioritize one or the other. And I try not to do that, because I know I'm always going to be in a space where there are both Latin and African-American or Black, either students or people who are just aware of my identity. So I try not to pick one over the other. My mother, she's Black. My father's Panamanian. And so choosing one or the other is like just having half of me. I need my full self. And so it's a one complete identity, not a compartmentalization of my identity. And so when I'm in spaces like that, I try to bring my full self. I make it known that you have an Afro-Latino here. I am going to speak loudly I might speak in Spanglish. At some point, if I am fired up, you're going to get some Spanish out of me. I might be playing some salsa music at some time if you step into my office. And so it's that flavor. So it's the sabor, that's flavor, right? So that's my flavor. That's my uniqueness. And I live in that. I love it. And so it's very, very rare that I prioritize. Sometimes it becomes beneficial. And those are the instances where I might prioritize, because then it requires me to communicate to whoever's in that space more effectively, to connect with them initially, to say, hey, yeah, I understand you might be having a good time. Let me put my Latino hat on, just that one, right? Let me put that on first. Let me introduce myself to make you a little bit more comfortable, and then say, oh, well, okay, so I'm Afro-Latino. It's like, okay, yeah. I kind of gathered that. Brown face. And then it just to help whoever I'm talking to build that connection. And then it's, oh, well, here's the rest of me, right? And so sometimes I do that, sometimes I don't. But you have to find kind of like a happy medium in between. And so there are times when, if I'm with my father's side of the family, we're going full on Panamanian. We are bringing that Panamanian passion. We're going, full of Spanglish and all that other stuff. It's a fun time, but we don't forget that we are also Black. So we are also Afro-Latinos. So it's a rare occurrence that I am required to do that, but it only happens in a short amount of time, just to make someone else more invited, especially if I see, they're the only Latinx person in the room, I will do that to make them feel more comfortable, so that they're not the only one, because I know what that feels like. And then I'll say, okay, yeah. And then we'll be talking, and then if they're fluent, they'll continue to talk. And then I have to step in and say, okay, well, I'm a little embarrassed. I'm not all the way fluent, so let's talk in English a little bit, because we're in an English speaking space. But it's a very rare occasion, but I only do that to make someone else more comfortable, if that makes sense.
No, yeah. That's great that you kind of use it to help other people and not just like for your own advantage, I guess. But it's also really nice that you're pretty in tune with both sides of yourself and comfortable with, no matter what space you're in, you can sort of still stay grounded in your identity.
Mm-hmm.
But going back to like NASA, how do you think one of the biggest institutions in the scientific field can help like take action, not just through you, but as an institution, help take action to increase minority representation?
Yeah, so it's one of the ways that's happening right now is the NASA SMD Bridge program. So I'm on that organizing committee, and so that is a big thing that NASA is doing right now. And if the agency higher up, or if NASA admins is listening to this, then I encourage them to continue efforts like this one. I encourage them to do more, not just the one thing, because they're not going to have, excuse me, a silver bullet, if you will. So you need many different things. You need many different methods to kind of combat, to kind of diversify the field. NASA has near infinite number of resources. They're like the astronomy gods. They can do it all. And so I implore NASA to continue doing that. There are wonderful people that work for NASA that want to do this work. They just need the resources and the opportunity presented to them to do it. And so that, again, it's just opportunity and access. And then the resources will come. But NASA has to make this a a priority, which I think they're on the right path to do. We've read the decadal survey, it's in there, chapter 3. But you know, there's still a lot of work to be done. Chapter 3 was just an introduction, just an eye opener. And so there's a lot of work to be done. And I think NASA can do that if they stay on that right track.
Yeah, that's good to hear some optimism towards NASA these days in that space. I think they have been doing some good things for sure from the student perspective that we've been talking about. But as always, more can always be done. And we have to keep pushing to make this field a better place. So yeah, so now getting into sort of your future, where do you see yourself in 10 years? Ultimately, what do you sort of hope to accomplish with your career now that you're sort of in this position at NASA that you've sort of been like working towards for so long?
Yeah, wow, 10 years. I hope in 10 years that, you know, I might have less gray hair. I don't have any right now, but I hope that I don't have any gray hair. I'll be in my 40s by then. But so I'm 33 now. And so in 10 years, by 43, I hope that I can take what I'm doing now for NASA and turn that into one of those much larger nationwide programs. Turning into, so right now I'm leading an initiative, an effort to go around to HBCU physics departments and to talk to them, engage in them, and to tell them about these opportunities that are happening at NASA, get them aware of how to make their applications and grants and things and fellowships more competitive. When they're applying to NASA, there's NASA Roses, Inspires, all these opportunities are there. They just need to be aware that they are there and they are for them as well. And so that's what I'm doing right now. I would like that to be expanded much, much larger, to include not just HBCUs, but other MSIs, HSIs, community colleges, and to then say that, you know, all are welcome at NASA. You can get here. The other side to that in 10 years, I would really like NASA to include more theory work. So as one thing, as a theorist, right, another side of my work is to communicate my science in a way that can be applied to NASA missions, right? So we know that NASA science is all about NASA missions. If it doesn't fit into a NASA mission, it's extra, right? It gets, you know, maybe we might be able to add that on, right? But communicating that is difficult. And so I've met tons of students who have an interest in going into theory, who have an interest in saying, yeah, I want to do what you're doing, but you know, it's hard to do that. It's like, I know it's very hard to do this, but you can do it if you know how to survive while doing it, right? And so I would love to see in 10 years what I'm doing to not just be some of the diversity, equity, inclusion work. That's fantastic. I'm going to continue to do that as long as NASA's paying me. But I would also like to see more developments on the scientific side as well. The scientific communication, not just communicating images that we've taken, but how did you take this image, right? How are you doing this theory work at NASA? I get that question a lot now. How are you doing this at NASA? I thought NASA was just observation. No. Well, they need people to develop the science and the theories that will then make this mission successful. That's part of it. And so I would love to see NASA kind of expand those communications. And I think that's an easy task to do. It's very easy, very doable in the next 10 years. And then support, having more and more support for the smaller schools. If they don't have PhDs in physics or astronomy, they can still support, because those are where your students, those are where your postdocs are coming from. And so there are some HBCU alumni at Goddard, some of them are my friends. And so I would love to see more and more of that culture there in the next 10 years. And so if I have anything to do with that for 10 years, as long as, if NASA doesn't kick me out by then that's what I'm going to continue to do. But I'm looking at, I hope to have a long career at NASA, for in whatever capacity I can, for DEI, for research in jets, for research in theory. I want them to do more general relativity. But overall, it's the communication of how things are done, right? Which outside looking in, it's very obscure. How do you construct a mission? What is mission architecture? Things of that nature. And so that's what I want NASA to kind of, the direction I want them kind of be focused on. And so NASA administration, if you're listening to this, I have some ideas. But that's 10 years, that's kind of the dream. And I know some of that's not going to be practical. We know we're up against funding, we're up against Congress or whatever, and any other thing that might happen in 10 years for society, right? There's societal influences overall, but that's kind of the dream for NASA in 10 years. And I hope to be one of the ones leading some of those efforts as well. So.
No, I'm sure that'll be the case. You have so many great ideas, and we're looking forward to everything that you'll be able to accomplish within the next 10 years. But you touched base a little bit earlier about Black and Astro. So what does the future hold for you guys? What are you hoping it's going to look like? And how can people that want to support your cause do so?
So we are, and I have to make sure I'm not revealing too much too soon. But there's a lot of planning being done in the works for many events this fall. So we are, and these are events that are open to anybody, right? So I would love to put on, and this is an effort that I'm leading, and so I can say this, putting on workshops for evaluating grad school applications, fellowship applications, double checking them. The NSF GRFP application, it's an obscure one. It's a very competitive one, but we have a network of people who've done that before. And so I've done it myself personally. I've gotten 3 students overall. The many years that I've been mentoring students, 3 of my students have gotten the NSF GRFP. So, and presidential fellowships and other fellowships. I had one student, she's at Georgia Tech. Kosa Johnson, if you're going to listen to this, you're one of them. So one of my best and brightest. She got $1 bajillion for grad school. She's funded for 1,000 years now, and that's one of the shining highlights. Like this, you can be one of them, and so that's part of the motivation for workshops like that, and then other professional development workshops as well, right? How do you communicate your science effectively to someone who's not an expert? How do you do that in an interview where you have literally a finite amount of time? You have 30 minutes maybe in an interview to communicate what you did over 5 to 7 years in grad school. How do you do that? How do you present posters more effectively at conferences? How do you network? How do you reach out to people? How do you get the courage to cold email somebody who's at NASA, who's somewhere else? How do you, how do you develop those talents? And so that's some things we're going to be putting on into the fall. We have other efforts that are very monumental that I can't speak on, but do check out our website, keep up with us. And I would say next summer, we are trying to plan an in-person conference. So that is, that's the big one that I think I can say. And if I can't say it, then Ashley Walker's going to be mad at me. But Sorry. We need more exposure. But that's one of the big ones. And it's a dream of ours to have this in-person conference, and we are inching closer and closer to it. I think we are almost there. So do keep up with us when we announce the other events that we'll have. Look out for those. We're constantly updating the website. That's part of my task. And so there's going to be new website developments. I'm going to update the design of the website pretty soon. We may have some interactive features on there, so do check that out. And gosh, I guess that is all that I can say right now, because I don't want to reveal any other surprises we have coming up. But we do have some surprises coming up for Black and Astro. So there's a lot of things that will be happening this upcoming academic year. Most of them will be free. So they're all, of course, all of these things we are trying to put on for free, no cost to our attendees. We want this to be as accessible as possible, so that people can learn and gain and grow and have fun with us. I think we might put on another movie night. I don't know. We'll have to ask Keyshawn if he wants to do another movie night. But yeah, that's what's happening in Black and Astro. We've got a bunch of other things coming up. The next 5 years, our 5-year plan is to have a national conference at some point. Yeah, so it's going to be big. And if I revealed something I wasn't supposed to, Ashley email me, not them. Be mad at me. Don't email Goku. He didn't do it. I did. So, yeah.
Sorry, go ahead, Dr. Gamble.
No, that's what we have planned for Black and Astro. So I'm trying to contain my excitement, basically.
Yeah, those are all extremely exciting things, and I'm very excited to see all the amazing things you guys are going to do this academic year and the future. Just a quick follow-up, just to sort of for the community, how can we support you guys, like Black and Astro as an organization, if we're not directly involved in it? Like, what are steps that we as the community can take as individual scientists to show our support and to sort of expand your guys' reach in the community and things of that nature? So what do you think that we can do?
Yeah, you can support by, it's something as simple as just retweeting. Retweets, likes, sharing some of the materials that we put out there. Going to your meetings with your faculty members at your universities and saying, hey, have you heard of Black and Astro? Have you heard of Ashley Walker? You probably have, but have you heard of Dr. Gamble and Keyshawn Ivory and Caprice Phillips and Dakota Tyler and Robert Washington and AJ Link and Brene Hadnot and Cheyenne and all of our other team members for Black and Astro, and communicating really the need for the support is probably one of the best things you can do. Communicating that need. And then also, if you hear of other things that we haven't heard of ourselves, feel free to share it. Please share. We're always looking for collaborators. We're always looking for people to support us, either with manpower, volunteers, financially, of course, is a big one. And so that is a major way to help out Black and Astro, is to share the word, right? So we're largely word of mouth. And so sharing that is fantastic. You're doing your part if you do that. And we congratulate you. We thank you for doing that as well. And if anybody listening to this has any ideas for collaboration or sponsorships or partnerships, let us know. Feel free to reach out. You can reach out to me on Twitter. My email's up on the website. You can email blackandastro gmail.com. And yeah, we're always welcoming new ideas and new partnerships. And so that's one thing. And if NASA's listening to this, NASA, I would love for you guys to be a part of Black and Astro. It's some of those places are very hard to collaborate with, right? Because they're very large institutions. Some have red tape, some don't. But I implore people to leverage their networks to support Black and Astro. Leverage the network. And show up to the events when we put them on, because yeah.
Definitely, yeah. So I think that's a very good message just for the community and everyone listening to this. Support Black and Astro. They're doing amazing things. So yeah, so we're almost reached the end of our interview. So we like to always end with a couple of quick hitters just for fun. So the first one is, I noticed recently you were tweeting about Attack on Titan. So I have watched the show and I've also read the manga, so I know the ending. So I was wondering, what are your top 3 favorite Attack on Titan characters?
It's kind of contradictory. So I literally just finished season 4, part 2 this morning, and I am like, what is happening here? And so, man, one of my favorite characters, was, gosh, and her name escapes me, the female Titan was one of my favorites, only because she was pretty badass, and she, in the beginning, when we were introduced to her, she was pretty rogue. So she wasn't like picking a side. She was just, I just want to do my own thing. I don't want to be a part of y'all's fight, but if you're going to include me in here, I'm probably going to win. And she kicked butt. Like, it was the first episode for the female Titan was like, I watched it twice because I'm like, wow, you guys have to step your game up now. And I'm on the fence of, I guess number 2 might be Eren Yeager. He grew on me initially, and then towards the end of part 2, spoiler alert, he actually does, well, he flips on us. He lies to Zeke, and I'm like, wait a minute, Zeke's your brother. Zeke was one of the favorites, right? So, and I liked Zeke too, but I'm like, man, Eren, you really threw us for a loop there. And then if you've seen the end of season 4, you know he completes what he set out originally to do, and it's like, man, he actually did it. What's gonna happen next? Oh wait, Attack on Titan's canceled. No. But I did hear they are coming out with a part 3 next year. So I think we get like 10 more episodes, and then they're just calling it quits. So that's my top 3 right now. If I had to extend it to maybe like top 5, I might include one of the generals in there. He went out like a G in those last few episodes. And so him and another character, they went out like bosses. And so they've got my respect for that, because they were pretty badass as well. But those are my favorites. Those are my favorites in Attack on Titan. That female Titan episode was crazy. It was nuts.
That's a solid list. Yeah, that show's wild. Crazy show. Yeah, so next I wanted to ask, I think you know Isaiah Holt. So he's one of my good friends, and he was showing me that you went to Dreamville, and we were both very jealous. So I assume that you're a J. Cole fan. Is that correct?
Of course, yes.
Okay. So I would like to know your top 3 J. Cole songs.
Oh my gosh, this is hard. Man. So J. Cole, and I think this was on a mixtape. I think this was on Friday Night Lights, the mixtape. He had a cover of the beat to Souls of Mischief's 93 Until song. It's an old song. So it's old school hip hop. But he did a cover to that song. He used that beat, sampled that beat, and I think it's a song called 03 Until. That's one of my top 5 J. Cole tracks. It was an iconic beat. He did justice to, and then he killed the song as well, killed the track as well. So one of the top, it's a lesser known track, but if you're a J. Cole head, you know what I'm talking about. The other one, man, this is a really hard question. The other one might be, it's not a song, it's not a track. I'm sorry, I'm breaking the rules. It's not a track, but that Revenge of the Dreamers. Revenge of the Dreamers 3 takes it. Yeah, it takes it. You had Middle Child on there. Earth Gang collabed with him on there. You had a whole bunch of people. That kind of takes the cake. And then, man, I guess to round out a top three J. Cole songs. I should have went through my library before I came on here. Oh man. I would say No Role Models. No Role Models is a great track. Only because kind of J. Cole's upbringing was a little similar to mine, not exactly the same, but in terms of inner city kid, we bounced around. Both my parents are from New York, they're from Queens. Grew up in a single parent home. It's the no role models, and then continuing that through your career as a teenager, as an adult, and it's just okay, yeah, I connect with that. He's speaking the truth. He's speaking some truth here. So no role models for me. That was a hit. But I mean, I could continue on. There's Land of the Snakes. There's what? You have the whole entire Illuminati mixtape. I could keep going on. But yeah, gosh, that might be one of the hardest questions today.
That's a respectable list, though. The next quick hitter is your top 3 favorite facts about black holes. This one's hard too.
Okay, so top 3 favorite facts. Let me see here. Okay, so this is in no particular order. So anybody who might tweet me later about this is in no order, and don't take this to heart. But all right, so my top 3 has to be top 3 facts are the concept of frame dragging, where you can enter into the orbit of a black hole opposite to its rotation and be forced to rotate with the black hole as well. So frame dragging, that's one factoid. And as you are doing that, you are actually aging slower the faster you rotate. So it's a relativity thing. So that's one of my top 3 things. And we're still trying to figure out why the crap does this happen in the first place, right? We're still figuring that out. Another one would be, Another one would be the fact that we can't observe, or this is the no hair thing, where we're only observing mass, spin, and charge of a black hole, right? And even charge is very obscure. So mostly it's just mass and spin. And then you can calculate area, but that's it, right? Mass, spin, area for a black hole. So it's the no hair theorem, and it's really the obscurity of that fact that if something goes into a black hole, we can't get it out. And if it does come out, theoretically, right? Nobody kill me on this on Twitter for this. If we do hypothetically get something out, it's not going to be the same thing. So that is something that's very interesting to me, and it really captured me when I was in undergrad. It's like, what do you mean something can go? It's a one-way entry. What are you talking about? We have to have something to come out. No, if it goes in, it's it. That's gone. It's gone forever. So, you know, if you haven't taken your qualifying exams yet, throw them into a black hole and get rid of them. That's one way to just, you know, pass by default. You can't get them back out. You pass by default. The universe passes you. The last little factoid is, is that we can describe one of my favorites, and this is really more mathematically heavy, so this hasn't been observed, is the fact that we can describe black holes, especially rotating ones, as wormholes. So this is what we call, the actual concept is called an Einstein-Rosen bridge, or wormhole. We can describe black holes mathematically as wormholes. And so that's the other half of the mathematical solution to black holes. Well, there has to be another side to spit you out. But of course, there's other implications to that: negative matter, negative energy, travel faster than the speed of light, try not to get crushed, somehow survive, right? If Interstellar can do that, so can we. But those, I have to say, those are probably top three, no specific order. Now, if we observe wormholes, then wormholes goes to the top, because that's like, what? This is science fiction in real life. But yeah, top three black hole facts. Fourth one might be the fact that they don't, this is a bonus, black holes are actually very light. So then yeah, if you actually calculate the density of a black hole, some black holes you could float in water. They're very light. And so, yeah, but these are the small black holes, but even some of the more massive ones, they're still very light in terms of density. So we think of density, think floating. Black hole theoretically could float. That's a bonus fact for you. Yeah. A lot of people don't know that, but if you're in the field, you do the calculations. It's like, this is a weird number. Yeah, because it's a lot of empty space.
Yeah, those are all crazy. Those were pretty mind-blowing facts. Thank you for that. Last one really quick before we finish off. What are your 3 favorite restaurants in the Maryland area?
Oh my gosh. Well, there's one, man, you guys are really asking hard. These are the hard questions now. Not the, how did you navigate through? No, these are the hard ones. Okay, so in the DMV area, me and my wife usually we love going to this one restaurant. It's called La Vie. So it's I believe it's a French Mediterranean restaurant. And it's down by the wharf. So if you're in DC, down by the wharf, it's an amazing spot to go to. The food's great. They have this like drink that comes in a little house. They smoke the whole house out, and they bring it to you on your table. And when they open the door to this little house, all the smoke comes out. And you literally have a fumigated drink in there. So I'm sorry, kids, you can't have this. But when you turn 21, then go to La Vie and order this. Sure. But if you are of age, go get this drink. It's amazing. It's like an experience. I wish I could show it to you. It's an experience. So that's one of the favorite restaurants of ours. Another favorite is called the Hamilton. It's downtown DC off of F Street. And it looks like the architecture, the design inside the Hamilton, they have very, very tall ceilings in there. And it's filled with like all of this like National Gallery-esque artwork in there. And it looks as if you are in a museum or something and you're having dinner right there. And it's a very large restaurant. They have a performance space in one part of the restaurant. Downstairs, they have large open areas for dinner. They have 2 bars. It's amazing. And the menu's awesome. The menu's amazing. So people at Hamilton, I'm giving you this is a hot take, a good review. So next time I'm there, remember, this is Ron Gamble giving you a good review. This is your Yelp review. I guess lastly, one of my favorites, and this isn't it's not a fancy pants restaurant. It's one of my favorites is, it used to be called Farewell in DC. It's an all vegan restaurant. But it used to be called Farewell. It's called Sticky Fingers now, which Sticky Fingers is the bakery as well. So it's a restaurant and a bakery. But it's an all vegan restaurant. My wife's vegan, so I had to learn how to appreciate vegan food and things. And it was very interesting, but I really love this restaurant. It's nice, it's quiet, they've got a great menu. You know, it's all plant-based, so it feels like you're eating healthier. But if you order like a stack of waffles, then all the carbs isn't that good for you. But it's a fantastic restaurant, and I love it because it's a nice place to just relax in the back and just chill. You just want to go out, grab a bite to eat, grab something cool to drink or something in the summertime, in the winter, or whatever. They have hot foods as well. It's a nice place to just chill out in the busy DC city. And so that's tied. I have to give you a fourth one. It's tied with Busboys and Poets. It's a staple. I can't say top restaurants without Busboys and Poets. A lot of people have been there. It's one of my favorites as well. So it's tied on my list with Farewell or Sticky Fingers. And the food's awesome. It's great. The library's there. It's a bookstore, restaurant, performance space. Like, what more can you have? And it's awesome.
I actually got this book from there.
Oh,
yeah, it has an amazing book because
yeah,
trying to learn to cook some Filipino food for Simi. I live across the street from Busboys and Poets, like literally across the street, because I live in Hyattsville.
Oh, okay, so right, okay, cool. Yeah, so I live in Bowie. We need to grab coffee at some point.
Yeah, definitely. But yeah, so that's all we had. Thank you so much, Dr. Gamble. It was amazing talking to you. I learned a lot. I think
Yeah, that was awesome.
This was really good for the community. We're really excited to put this out. Thank you so much.
Thanks for having me. This is Cosmic Crusaders. You guys continue to watch their episodes.
Thank you
so much.
Much appreciated, Dr. Gamble. I'll probably see you this academic year for sure.
Absolutely, absolutely. Please continue to reach out. You can share my contact information if you want. I always make myself available. If you have questions, students, if you have ideas to bounce off me or questions or concerns or something, or you need to navigate something, or need advice, send me an email, reach out. Yeah. And support Black and Astro.
Yes.
Yes, definitely. Well, thanks, Dr. Gamble. Really appreciate it.
All right. Thank you.
Take care. Have a nice rest of your weekend. Thank you so much again.
Thanks. You too. Bye.